Okay. Actually, I'm also gonna go in a very similar direction as Liliana and Diego, because I'm also coming from rehabilitation robotics. Also currently mainly working with spinal cord injury patients or users, as I would call them. And currently I'm working with the Eastern Switzerland University of Applied Sciences. There we have a small group where we develop robots mainly for personal mobility, speak wheelchairs and exoskeletons, and the merger of the two different approaches. I'm not going to dive too deep into what I'm doing in my everyday job, but for today I'm going to very strongly advocate for human-in-the-loop systems when it comes to medical robots and artificial intelligence, because as probably all of us know that if we over-automate, that leads to a huge lot of risks and to very unhappy customers in the end. We did a lot of user research. Our main focus in any project is that we really try to do user-centric design, user-centric development with all the stakeholder groups involved in the very early stages of any development. And one thing we learned from basically any interview is that the users want control over their mobility devices. They want to be in charge of what happens and they want to be able to decide at any moment. So what has never worked so far is that if you put a human in a mobility device, it just transports as if you're using public transport or something. That is not going to make your users happy. Also from the other perspective, I identified 3 factors which really force this collaboration between the technology and the user, one of them being the safety. So if you have a system with a lot of technology and a user inside, you can reduce the risks massively by correcting each other's errors. So if the technology makes a wrong prediction, for example, if it's an AI, then the user can react. And if the user makes a mistake, as all of us humans do, then maybe the technology can react. So the safety is the level of safety is much higher if you have a human-in-the-loop system. Another aspect is definitely the regulations. I'm not sure how many of you have brought medical devices to the market. It's a nightmare, basically, with all the regulations we have to follow. And currently, also, the system is not made for any type of AI-based medical devices. So it's very hard to, as we all wish, the device learns about the patient and then adapts itself. That's a huge challenge to bring to the market. It's also a technology challenge, but it's also a regulatory challenge. Currently, the outcome of any medical device software has to be deterministic. So it's not allowed that it learns and adapts itself. So that's one of the aspects where I see that you need human-in-the-loop systems as well. And the third one is definitely the user experience. Because if you have a bad user experience for a user, the user's just not going to use the device. It's going to stand somewhere in the corner, either in the clinic or at home, depending on the device, but it's not going to be used. So my first area of challenge is basically environment recognition for the mobility aids. We started exploring this field a little bit with some cameras first, and then some depth images where we tried to detect stairs and steps. Try to find a system which proposes, hey, I think there's a step ahead and your trajectory should look as follows, because it detects the height and the depth of the step. We did have some decent results. It's probably okay, nothing which is ready for a medical device yet, but as I said, we're a university, so it's a start. But if you imagine again sitting in a wheelchair or standing in a wheelchair or whatever, walking in an exoskeleton, then your cognitive load is much higher because you need to find out how to navigate all the obstacles which are in your environment. And you also typically have to consciously switch a mode in your medical device you're using. And my challenge for you today would be, how can we reduce this cognitive load to the level of the cognitive load of pedestrians? Also, second one is, if you have an AI in the system and a human which does the final decision of what is going on now with my device, how would a user-friendly user interface look like? How can we make these systems really usable? So that's probably also for the breakout session going to be the topic which I would love to discuss with some of you. A second one, which I also, from my background, which is very close to me, is documentation. As you might have learned, I'm a little bit traumatized by bringing medical devices to the market. Documentation is a huge topic, and there's a huge set of documents which also increases the level of safety and which makes your product compliant with all the regulations. You have typically some database structure where you put in requirements, risk management information, also usability, standard testing, a huge lot of information. All of that information has to be aligned throughout the whole life cycle of your medical device. And it's typically maintained manually. I see huge potential for AI there, and it's also there in the end. If a human is somewhere in that system, and the system proposes, hey, I think if you have from your post-market surveillance that there's a new risk coming up, then it could also propose, hey, maybe in the user instruction we need to adapt at this point, and then in the end a human should decide what is really happening there. So that's a second level of challenge. I think we won't discuss that specifically today, but I'm also happy to discuss that type of stuff in the break, or whenever. Just get in touch with me. I would love to bring that field forward as well. So, quick summary. Today, I would like to foster a partnership between the users and the AI and increase the safety, regulatory compliance, and also the user-centric experience.